everyone to the 4th Rasa Community Meetup local to Berlin. I'm Emma, the Community Manager at Rasa, and I'd just like to pretty much start by saying thank you so much for deciding to attend our meetup during the challenging times, obviously, for everyone. Really appreciate, obviously, the opportunity to connect with you all remotely. And yeah, I kind of started a poll in the Zoom webinar as well. So if you have a chance maybe to let us know if you've been to a community meetup before, it's always really interesting to hear from you if that's the case, or if maybe in the chat you want to let us know if you're maybe local to Berlin. And yeah, so we have 2 really awesome presentations up for you today. First up is our own research advocate, Vincent Warmerdam, he's going to share some of the projects that our research team has been working on. And by the way, another FYI, he's also got some really awesome videos on our official YouTube channel. It's called the Algorithm Whiteboard, so definitely check out the series. Maybe you will probably talk a little bit about that too, Vincent, and introduce that more about what you're talking about there, but definitely worth checking out. And after, we'll also be joined by Rasa Contributor Divyang Pradeep Pal, who's been working on a really super exciting project. I've been just really dying to see the next steps and everything that's kind of following. He's been working on some really great also tutorials that he shared on this. And he's going to basically share his experience integrating Rasa chatbot interface into Unity, and pretty much I think he will also mention things on how you can do it yourself as well. And also just share his journey. So I just wanted to say also thank you so much, Divyang, for taking your time out of your busy study schedule. I know you're studying hard to be with us today as well. So thank you so much for that. So yeah, I guess maybe we can even just hop right in. We'll start with Vincent. So yeah, thanks, Vincent.
Hi everyone, my name is Vincent and I am the research advocate here at Rasa. And I'd like to spend a little bit of time explaining what that exactly is, because it's not the average role you see at a tech company. Now, there's a lot of stuff that I do over at Rasa, and you're probably aware of our YouTube channel. And it's not just me making content there. There's the masterclass that you're probably aware of. You'll also see all the Rasa conference videos there. There's a nice one by Maddie. You'll probably also see my colleague Rachel. She has a couple of playlists that are definitely worth to check out. She has the NLP for developers. Those are short videos that explain topics in NLP. But she also does a lot of live coding. And in particular, she's done some good work in the Alexa integration, which can be tricky. But she has a nice little diary of how to set that up. That's definitely worth your time. But what I do, and you've seen it reflected on the YouTube channel, is I typically try to focus my attention a little bit more on what people on our research team are doing. So that means that a lot of common algorithms in NLP, that's something I try to spend a lot of time on to make sure that all of the developers in our community are aware of, and also how they work. And that's kind of what I do. I'm a research advocate, and I'm here to explain what the research team in my company is doing. And that means that pretty much you can ask me anything. I take requests for the YouTube channel. But it also means that part of my job is content. And if you have been paying attention to the blog, you might have seen this blog post that came out. I think it was yesterday, might have been the day before, where I have a small tutorial on how to use tensorboard. That's a feature that our research team has been working on for a bit. Another bit of content that you'll see soon is a bit of content on Spacey. So I wrote a guide on how you can get a custom Spacey model fully integrated into Rasa. Definitely check that out. And I think next week there's also going to be a tutorial on how to use BERT in your Rasa pipeline. So these are the kinds of content that I focus on, and this is the kind of stuff that I really like to, to make sure that people can pick up. But that's only a subset of the things that the research team does. And what I like about being able to talk today is the stuff that I usually write content for. That's stuff that's in production. That's stuff that's made it there. And today what I can do is I can talk a little bit more about, in the life of the research team, well, there's just some stuff that we're working on. Not everything that we're working on is going to make it to actually production, but I think we're doing lots of interesting things, and I just figured I'd share some of the ideas that we're currently playing with. In particular, I'm going to talk about some hyperparameter work for the diet architecture. I'm going to talk about some new entity features that actually made it to production now. I will talk a little bit about some experiments with generating training data. And what I'm also going to do is I'm going to talk about some of the open source work that I have been working on to support both you, the community, as well as our research team. So I hope we're all pretty excited about that. If you've been paying attention to the forum, you might have seen this feature, and there's something really cool here. So just to check if the pen works, yes, it does. That said, I do want to talk about this one new feature because I do think it's relatively sweet and also like definitely on the useful end of the spectrum. So in Rasa, as some of you are probably aware, if you want to say like, hey, Berlin, that is an entity, the way that you would specify that is by having this sort of DSL. You would have square brackets around something that is the entity, and then behind that you would have a circular bracket that says, oh, that's the type of the entity. And you have that over on the left-hand side, and you got one over here as well. And detecting these entities is useful, but if you think about this particular use case, I want to fly from Berlin to San Francisco. What would typically happen now is that both of these entities would go into a action server or some custom Python code, and then your code would have to figure out that this is the destination and that this is where you're flying from. And we were wondering, you know, this is an example where you might be able to add a little bit of context to an entity, but there might be more of these examples. So the research team has actually been focused and came up with an idea here. So what you can do now is you can use a very, very similar domain-specific language here. But the one thing that you're able to do is you can specify, well, there's an entity, and that's the city. But that city also has a role. In this particular case, Berlin would be the departure city. And what you can then do is you can have another role that is the destination. And this should make it such that your action server requires a whole lot less code because we can predict this context on your behalf. And it won't just be roles. What we can also do is have this notion of, say, a group. So in the situation that you have a chatbot that has to order a pizza, you can say, hey, I want to have like a small pizza with mushrooms and a large pizza with pepperoni. Then it would really help to know that the mushrooms is part of a group, that is part of the first group of what you're ordering. And also that is some context that we could go ahead and give you. And we think that this is something that will make your action server just a whole lot lighter. But so we came up with this. We figured this would be a useful thing to make, but then there are lots of ways of implementing this. So a large chunk of the research team's time was thinking like, hey, what's the best way to model this such that in most situations, this will work out fine. Now, the way that we've solved it, and I'll just use the diet architecture as an example, is we said, well, we can change a lot of things, but let's just, for this one use case, only add behavior at this part of the architecture. So only at the area where the entities actually get predicted. And what we've done is we've said, well, if we just look at the transformer layer that we started with, so this would be the transformer layer over here, then in the normal situation, part of that output would be used to classify the intent, and some of the outputs would be used to detect the entities. But what we're now doing is we're saying, well, once these entities have been detected, let's use the same block as for the entities, but this block is going to predict the role. And the idea is that the output, like, hey, we're predicting an entity here. If we combine that with the output from the transformer layer, then we can pretty much still use the same diet architecture. We just make a small adjustment on that, on this particular part. And then the first conditional random field will be used to predict that the airport is Berlin, and then the second block can say, well, and that is the destination. And this is we still have to do some extra compute, but we can keep most of the architecture intact this way. And so far in our experiments, this seems to work quite well. But there's way more happening inside of, this diet architecture that we have, because just from staring, like, even if you don't exactly know what this diet architecture is doing, just from counting the number of blocks, you might be able to imagine that there are a lot of hyperparameters for this system. So, let's come up with a few. I mean, there's the number of feed-forward layers to use. That is something that you have a hyperparameter for. The number of layers that we're using here, that's something you have a hyperparameter for. I suppose which sparse features are we using? Are we using masking, yes or no? How big are these embedding layers? It's a long list of things, a long list of settings that I could be using for this system. And that actually poses the research team with a pretty fundamental problem. Because when you think about it, we don't necessarily have a very large corpus of very representative data sets. We would love to have data sets that are representative for a chatbot across many different languages, but that's a data set that's hard to come by. And yes, we have clients, but we don't expect our clients to just hand over all of their data for our research. We typically have to respect that they want to keep the data on their own side. And, you know, there's different languages which are a problem. We also do not fully know if chatbots across all different domains, if they require the different hyperparameters. And, you know, one of the key questions that we have is, what is a reasonable starting point? And can we make it easier for people to run or interpret these different models? So what we've been doing, I believe, in the last release is we've found, at this point, I think we have 6 data sets that we consider relevant enough. And what we're doing is once every few releases, if we add a new data set, we're checking which hyperparameters in general work the best. And then these become the new defaults. So if you're going to upgrade soon, you may notice this. Like, we are changing these hyperparameters whenever we get the idea that there is an improvement to be made in the general case. But like, the question is that enough? Like, that's something that we're seriously struggling with. So we're definitely out there to help you to have like meaningful, good base parameters to start with. But instead, we also wonder, like, what else can we do to make it easier for you, the user, to have a bit of a principled approach? It will be nice if we can make it very that we can almost have a qualitative argument to say, well, these are parameters I should set for this one chatbot. And that brings me to a small announcement. I've been working on a little project. I would like to emphasize that this is not officially supported, but I figured sharing is best. And the name of the project is rasalit. It is named after Streamlit, hence the wink in the name. But the idea is that this is a command line app that is going to help you figure out the best parameters for some of your experiments. And what I would just briefly like to do is give a really, really short demo of some of the stuff that's currently in there. So what I'll do now is I'll just open up VS Code. So this is just a terminal for all intents and purposes. And what I have in here is the rasalit command line utility. And this is something you can pip install with a Git link. But the idea here is that there are some command line apps at my disposal. And in particular, I'll just start up the Diet Explorer for now. There's always a demo thing that can be worrying. Just check this. Okay, same error. In that case, I'm just going to open up this from source. Sorry for that. Okay, so I'll just open that one. This one should work because I'm in the source folder. Let's type rasalit again. Okay, we'll try Diet Explorer from here. And this does work. Great. So what this does is this starts a server, and I'll just open that up in this browser. And the idea behind this is that this is the Diet architecture. And when you hover your mouse over a certain part of the architecture, it tells you which hyperparameters you can change if you're interested in changing that one block. So at the bottom here, I can see that the number of transformer layers is a hyperparameter. That's something you see at the bottom. And if I move my mouse cursor maybe to a feed forward layer, then you see that weight sparsity and the dense dimension is something that I can tweak. And this is definitely a version 1. We're going to extend this. But the hope is that whenever you look at, say, one of our research papers, then you go, oh, I want to change that one thing, then this is something that might make it just a little bit easier such that you don't have to look in the docs and try to find that one parameter. The hope is that this might help there. So definitely give this a try. Like, I'd love to get feedback on this. But this is not the only feature that we have inside of rasalit. there's actually one other one that I would just briefly like to demonstrate. And to demonstrate that, what I'm going to do, oops. And to demonstrate that, what I'm just going to do is I'm just going to go to the Rasa demo folder. This is for the Sarah chatbot. And what I'm going to do here is I'm going to call rasalit again, but this time I'm going to give it the overview command. So I'm not going to ask it for the Diet Explorer. Instead, I'm going to ask it for the overview. And this starts a different app. And again, I can click the link and it should open up something, and there we go. And what you're looking at here is, because the folder where I'm running this from is a folder where I have lots of models trained, what I can just go ahead and do is I can say, well, here's the folder with all of my grid search results. If you type Rasa test NLU, then you could be able to cross-validate. And what this app does is this app is able to give you a summary of how well your intents and entities work. And it's just meant as a basic summary, but it is also something that should make it easier for you to just run a couple of grid search experiments and see the results. And you can see the raw data as well. And I can show you the raw data. Again, an error, my bad. But I can show you the raw data as well. And the hope is that these sorts of apps might just make it easier for you to run grid searches, and hopefully also might make it easier for you to give us feedback on those grid searches. The idea is that we are going to throw some of our experimental tools inside of that rasalit, and that can also be an interesting way for people to help us think on how we should prepare models for you. So let's go back to the slides there. So as part of my job, like I'm a research advocate, but it also means that I get to do a little bit of open source work to make tools for both the researchers as well as for my community that I represent. So keep an eye on this rasalit project. Again, it's not officially supported, but we are definitely gonna throw some experiments in there. And because you can pip install it, it should be relatively easy for you to have a play with it. So this idea of making content, right? So I can make a tutorial, and I think that's definitely something I should be focusing on. But I've noticed, at least for myself, that I really like the idea of not just making content, but also making tools. There's something about being able to give a tool to myself that makes me understand it just a bit better. So the previous tool that I demonstrated, that helps explain model results, and that's definitely valid. But a while ago, I was also wondering, what should I maybe make if I want to understand word embeddings instead? And in particular, this has always been a thing that I was wondering about. So word embeddings, you've probably, you may have heard of this. The idea is that you're able to map a word to some number in a high dimensional space. So there's some vector that represents king, there's a vector that represents man, there's another one that represents woman. And I've always kind of wondered, you know, the king minus man plus woman, is that really sort of approximately equal to the vector of queen? That's something I've always wondered. And there's actually a bunch of questions that I've always wondered when I'm dealing with word embeddings. Like this relationship, is that true for every word-to-vec algorithm, for every language, for every data set? What about gender bias in word embeddings? That's, I think, a valid topic to consider. Does this hold for all analogies or just the man-woman analogy? So this is something I've always felt rather, interested in. This is a curious thing to sort of play with. But then if I look at some of the tools that are out there and available, like this projector from TensorFlow, like I think it's a pretty neat tool, and it's nice and shiny, and the 3D representation is nice. But the tool itself is not really helping me. I've always sort of felt that it's a nice visualization, but it's not a library that I can play with. So it always felt a little bit limited in what I could do with it. So that led me to open source another tool on behalf of Rasa, and that's a tool that's actually gotten relatively popular in the couple of weeks that it's been live now. And the name of that tool is Whatlies. And the whole idea behind the library is that it should be relatively easy for you to explore what lies in word embeddings. So I'm just going to give you a quick overview of what the idea behind the tool is. Word embeddings are supposed to be vectors, and if vectors are two-dimensional, they might look like this. So I've got vector A and I've got vector B. And because these are vectors, there's this mathematical operation that I can do. So I can say A minus B. That's something I can express. And I can also express A plus B. That these are mathematical operations that I could do. But there's a couple of other operations that I can also consider. So instead of just adding and subtracting, one thing that I could potentially also consider is I can say, how about I map A away from B? Well, that would look something like this. And I could represent that with A bar B, for example. That's a notation that I could use. And this is an interesting trick, because essentially what this means is this is all the information that I have in A that is not correlating at all with anything from vector B. And just like I can map away, what I can also do is I can map onto. So I could say, hey, let's map A onto B. That's also an operation mathematically that I might want to be able to perform. And if I then were to come back to man, woman, king, queen, right? Let's say that these were the vectors. What I could then do is I could say, well, let's just take queen minus king. If I were to sort of look at what this arc is over here, well, that's the exact same thing as what you see over here. And this is nice, but what I can also do is I can say, well, let's take now the vector of man and project that away. These are operations that I could do with word embeddings. And the nice thing is that these operations might actually have meaning. That's what the whole king minus man plus woman is all about. And the idea behind Whatlies is that you have a convenient API such that if you were interested in doing something like this, that the only thing you really had to do is define your embeddings like such, and that then you could say, well, queen minus king, or man bar queen minus king, and that you would have vectors that represent this. The idea behind Whatlies is that you just have a simple, playful API to just play around with this. And you might wonder, well, that's nice, but that's only for 2 dimensions. What do we do with word embeddings that have like 300 dimensions? Well, then we can do another trick that's actually pretty cool too. So let's say I've got vector A, B, and C here. What I could do is I could map vector B onto A and vector B onto C. And then I could say something along the line of, 70% of vector B is in vector A, and about 20% of vector B is in vector C. And maybe that says something about the meaning. If king and queen are very similar, then I would expect that this number over here is super high. And if king and fire hydrant are not similar, then I would expect that this number here will be super low. And that suddenly means that I have an x-axis and a y-axis that I can plot against. And it's this observation that's used a lot in the library. And it's also something that I think might make it fun and playful to explore what word embeddings are. So currently, this has been implemented, and you can use spacey, Hugging Face, and fast text word embeddings. Only a subset of Hugging Face at the moment, but you can also use BERT embeddings for this. And I'll just quickly look at the time. I'm just going to give you a very quick demo of what the tool might be able to do for you. So what I've done here is I've got my Jupyter notebook, I've pip installed this Whatlies package, and I've just created a bunch of embeddings. And these are objects from the library. And I'm saying, let's suppose that the vector for man is this, is in 2-dimensional case, and let's do it for all of them. And what I can then do is I can perform the operations that I showed you earlier, and that's also what's giving me this plot. I'll just zoom out a little bit. So the plot that I showed you earlier, that's maybe like 6 lines of code really in Whatlies. And then you can just go ahead and play with this. What it will be more fun is, it will be way more fun if we just use some word embeddings from an actual backend. So below is the code that you'll need to make something that's a little bit more impressive. This is an interactive chart. And what I'm doing is I'm saying, hey, let's take from Spacey the medium model that was trained on the internet corpus, and then take all of these words from that, and let's just plot them against the man-woman axis in the same process that I showed you before. And when you do that, you get a chart that kind of looks like this. And the nice thing about this chart is it's fully interactive. So you can zoom in and out, and you can see that little clusters appear of certain words. And you can see that man, woman, because there seems to be like a correlation happening here. You can see that man, woman indeed is something that probably correlates quite well. But one thing that's nice about this is this interactive visualization. You can click a button over here and then save this as a static image, but you can also have this interaction happen on your website itself. And that means that you can have fully interactive word embedding visualizations, let's say on your blog or wherever. What you can also do is you can take those embeddings that I showed you earlier, and you can transform them. A very common transformation could be to use principal component analysis. And what we do internally is we use the implementation that's inside of scikit-learn. But what you can do is you can take this embedding object, which is like a data frame, if you will, but for word embeddings. And you can say, hey, let's transform all of them using principal components. And then let's just use those two principal components to plot everything. And when you do that, one curious thing is that it's really clear that there's this cluster over here that's about royalty. So there's king, queen, princess, and that really seems to be quite a cluster on its own. And then there's still some other clusters. If I were to look over here, cousin, brother, sister, this is something that relates to family. And the word family is nearby as well. It seems that cat and dog are close by. And it also definitely seems that the colors are sort of clustered together as well. And it's this kind of playful interaction that gets me a little bit excited. I think if you want to explore a topic like word embeddings, which is a relatively complicated topic, then charts like this might make it just slightly more intuitive for you. And the interesting feedback I've gotten so far is that this library, when I made this, I thought it might be something that developers would really like to use to teach themselves a little bit more about word embeddings. But what I've come to understand is that developers are now also using this to explain word embeddings to, say, stakeholders, to make it just a little bit more intuitive what's maybe happening with word embeddings if you're giving that to, let's say, your chatbot, which has been interesting feedback. I had not anticipated that, but it's fun to hear. I won't be able to show everything that the library can do, but one thing I figured would be nice to mention is that I'm adding new types of charts, probably on a once every 2-week basis. So this is something I released yesterday. So what you can do is you can say, hey, from the spacey language, let's just take a bunch of colors and then maybe cat, mouse, rat, and then bike and car, and then you can plot the correlation. And then you can confirm that indeed the word embeddings for the colors are relatively similar. The word embeddings for all the animals are also similar, and bike and car is more similar than any of the other groups. What you are also able to do is put a metric in here, so you can, instead of plotting correlation, you can show the cosine distance. But again, this is one of those charts that will add to the interaction and allow you to play and understand the word embeddings just a bit more. As a final feature, I just wanted to mention that one of the main things that I'm excited about here is that I also support BERT embeddings, and Spacey supports a subset of them. But one thing that's interesting if you do it this way is that you can say, hey, from this language, let's just select going to the store. Let's pretend that that's the embedding that I would like to have. But then I would like to have the embedding for the token store in context of this entire sentence. And that means that the word store in context of going to the store, that should be a different vector than I will store this in the drawer. Here it's a noun and here it's a verb. And you can confirm that the vectors that we're fetching are indeed not the same. So I'm excited to play around with this. This will help me understand BERT just a bit further. And I hope that this is something that some of you will also appreciate and enjoy. Let's check the time. Okay. So these are some of the things that I'm doing, and oh, there's a question. I'll just answer that real quick. That's a somewhat unrelated question, so I'll come back to that when the talk is done. So so far, like this analogy and then these word embeddings, they're cool, right? And we can focus in on the algorithms. And I really fundamentally think that the research team has done some really good work with the dyed architecture, because there's very, very interesting properties that are in there. But if I'm going to be very honest and definitely going a little bit more towards the application of a digital assistant, then I should remind myself of this one phenomenon. If I were to draw a Venn diagram, then let's say that the left-hand circle is the data that we generate and train on. So when you're designing your assistant the first time, you'll come up with utterances and some stories, and that's just a good starting point. Like, you're gonna have to come up with something to start with. But then when you put it in production, you typically have this moment where the data that the users generate, the way that sort of your users are asking the question, that might not be exactly the same as the data that you're generating yourself. And especially if we're going to do a lot of grid search, then there has to be, some hope for some good overlap. So this is also a fundamental problem that the research team tries to think about. What can we do such that this overlapping area is as big as possible? Are there things that we can do to make sure that the overlap is bigger here? Because if we do that, that's going to be a big win for production use cases. And that's something that we really do care about. So the first thing that I would like to mention here is this is a community project that we also host. So there is this repository called the NLU training data. And what we do is we just make sure that there's a bunch of good examples that you can start with. So if you want to be able to greet, then we can say, okay, here's a bunch of nice English examples that you can already go ahead and play with. And it's crowdsourced. So if you are interested in becoming a community contributor, then this is also a way for you to sort of help us out. And we definitely appreciate any contributions made to this repository. The thing with that repository, though, is that it's not going to be perfect. It's just never really going to be. It's going to be very valid, but we were wondering maybe we can do something with algorithms here as well. Would it not be cool if we can help users generate valid training data using maybe generative algorithms? There's been good progress there. So that is something that the research team has also tried to pick up. So the idea is that you give us an input message, something like, I want to book an appointment for tomorrow. And that then we have some generative models. At the moment, we're considering Hugging Face models. And that from that one input message, we are able to generate lots of paraphrases that are all quite different, but something that is valid. And the idea is if you have just one input message like this and we can generate 20 of these paraphrases, that should be something that helps generalize. There might be a couple of sentences that you generate that you would not have thought of yourself, but something that would be asked by a user in production. Now, this is definitely an experiment. This is super new. It's definitely not in production at Rasa yet, but it is something that we have opened up. So I will share a link. There's a Google Colab notebook where you can try this out yourself. And there's also a forum post made by Dutch where you can leave feedback. We think that there's something really interesting that could be done here. And it's also something that we will be really curious in learning if this is something that will help your training pipelines. So definitely feel free to play around with this, and we'd be super interested in hearing what you think. For me, though, I was wondering, this is a nice exercise in generating more data, but I was also wondering if there was maybe another way to sort of explore this whole in production part of a digital assistant. So at Rasa, you might have noticed that we've started doing a little bit more dog fooding, as they call it sometimes. So last year, Alan was doing a lot of work there. We released this chatbot called CarbonBot. And the idea was that was something that we could actually put in production and also learn from ourselves. It's really great for the research team that we're generating our own data sets, because CarbonBot is something that's live and therefore is something that can be representative of stuff that our customers and our community members are going to do. So this whole idea of dog fooding got me started and got me thinking, because I'm doing lots of trainings as well. That's also part of my role as a research advocate. So then I figured, wouldn't it be cool if we could have some sort of a dog fooding like project that we as a community could all contribute to? It would be some sort of a hobby project where we could all learn about what a good assistant is. That would be something that we can all share and also all learn from. So with that, I would like to make a small announcement that I have made this repository for the Pokemon demo bot. It is, and I must stress this, it is definitely sort of a hobby project. We're going to put it My goal is to have it live somewhere and that we can also use Rasa X and explore all the features. But the idea is that this is something that I will use for my trainings, but it's not something I'm going to be making on my own. This is going to be something that I would like community members to also participate in so we can all learn from it. There's an interesting fact. I started this project last Friday, and Saturday I got a pull request in because someone uploaded the Pokemon database, which so this project might actually sort of go places I did not imagine there. But the goal is that this is going to be another place where we can learn from a chatbot in production, but I would definitely be interested in what community members can contribute to this as well. So if you're interested in getting started, this Pokemon bot will be another one of the demo bots that you can play with. The main idea behind this bot is that this is meant to be something for the community. And there's a reason why I'm in particular excited about the idea. And it's also that I think that Rasa is a large project, and I can definitely imagine that it's a little bit intimidating to make contribution easy. And I would just like to demonstrate that with one example. I made a relatively small change to Rasa. This is my first proper pull request. It is something that's going to make it a lot easier for people to file a bug request. Pretty soon, and I should stress soon, it's not in the release yet, but pretty soon when you type Rasa version, it's going to give you the version for Rasa, but also SDK, Rasa X, and it's going to give you all the information that we will need to help you debug. So then you only have to write down this one command, and you can immediately add that to the issue list, and then we know a lot of information that will sort of help us debug your code. What I figured would be cute for this one example is I've been working on this for like 10 days. I work at Rasa, but also for me, it can take a while before something gets properly accepted. But one thing I figured will be nice to do is everything just got approved. So this is my first proper new feature in Rasa, and I just click the merge button. And what I'm hoping is that the Pokemon chatbot is something that'll make it just a little bit easier for people to get started with the whole contributing, because I just want to mention contributing can take a while. I work at Rasa, and even for me, a feature like this might actually take 26 commits to actually get right. So that's also a reason why I'm relatively excited about the Pokemon bot. It might make it just a little bit easier for people to contribute as well. So that was my smorgasbord of things that we're doing in the research team and stuff that I'm working on behalf of Rasa. Remember that you can definitely ask me anything. I am making videos for the Algorithm Whiteboard. If you think, hey, it will be really awesome if this algorithm got on there, reach out to me because I do take requests. Same thing holds for guides on the blog. And you can definitely give me feedback either on Twitter or on GitHub on any of the new Rasa tools that I demonstrated here today. You can find me on GitHub for, again, the Whatlies package, the rasalit package, as well as the Pokédex demo. Find me there and I'll gladly help you get started with some of these tools. And please let us know if you find these useful. We like hearing from you. While I have you here, I figured it's also good to mention, we have this conference coming up. It's going to be digital. I believe that we are still interested in getting some proposals in. So there's definitely some slots for speakers. So if you've got a really interesting chatbot or you've done something interesting with Rasa, definitely submit. We are interested in hearing from you. But we also have tickets that are still freely available. So go to l3-ai.dev and check out the lineup of speakers because there's definitely some A-stars in there. So if there's any questions, I would love to hear it.
Awesome. Thank you so much, Vincent, for sharing all those projects that you're working with the community. There's so many, and actually there's so many interesting stuff. So I'm actually really looking forward to collaborating with you as well, with the community on some of them.
I think I can speak on behalf of Emma. If you have interesting ideas for the Pokemon chatbot, Emma will also check those out. I believe I can say that.
So someone asked, chat asked, could you talk more about the computational performance? For example, how would a chatbot with this architecture handle thousands of concurrent users? How do you deal with the scalability in this situation? Right.
Oh, okay, so that valid question. So some of the details of this, if you go to the YouTube channel, there is this diet architecture series. And in the third video, I actually do some benchmarks where I also try to show that there are settings for diet which make it just way faster. Documentation. Yeah. So I'll first answer the question about the computational performance. The way that you can set things up is technically you can put more Docker containers sort of in your architecture. So I'll assume for now that you're using something like Kubernetes. If you have a load balancer, then definitely you can reroute traffic so some of this stuff is handled in parallel. Typically, it's not diet necessarily that's the bottleneck here. One of the things is more the pre-trained word embeddings that you're using. If you're using something like BERT, that is really computationally heavy, then you will need a very good reason to use it, because BERT will definitely slow things down. And it should also be said that in some of our experiments, adding BERT doesn't necessarily make the performance better as far as grid search results go. So diet definitely can be on the slow side, but it's mainly due, at least in my experience, due to the pre-trained embeddings that you're using. So that's the main thing I would look at first and foremost.
Cool. So the next question then, so from anonymous attendee is, do you have any tips for someone who's migrating from imperative programming to this new approach?
That is a valid question. I mean, I'm assuming that with imperative programming, you mean a certain style of programming, and you're comparing that to the more machine learning approach that we're having here. There's lots of questions coming in. So definitely the machine learning is different, but know that everything under the hood is still Python based and NumPy and TensorFlow. So it's still, you could argue that there are more imperative languages under the hood that are running the code on your behalf. What I would ask you in this particular case is I would be really interested in maybe having like a quick one-on-one with you, maybe on Twitter with a personal message, because I might be interested in exploring content that doesn't require any Python knowledge. If that is something that you're interested in, let me know. I would love to get some feedback on that.
Awesome. And so Michael Bateman asked, is there a limit for the number of words you can throw at Whatlies?
I mean, probably. Like I in practice, I've not really found it, but like I think it should definitely handle like a couple of thousand words. It depends on what you're trying to plot there. The main thing that is a hard limit, if you're using the interactive plotting, like when you can zoom in and out and whatnot, I believe that there is a maximum from the Altair library there, because the browser can only handle so many points being drawn interactively. And I believe that's, I think it's 1,000 or 5,000. It's in that margin at least. So 1,000 words being plotted should be fine.
Great.
And then is there some...
yeah, go ahead, Vincent. Feel free.
No, sorry. I suppose I went too fast there. But this is a question from Laura Simons. Is there documentation about different blocks in the diet architecture? Yes, it is on the documentation page. Like the interactive thing that I showed is not quite there yet. We're making some iterations, but you can definitely find documentation on diet that way. We also have 3 videos on our YouTube channel. And what can you expect to happen when changing a specific hyperparam, or is it purely experience? I mean, so technically a hyperparameter here is what pre-trained network do you use? And I guess you could call it experience, but if you use a very heavy pre-trained model, then it's going to be slower. So some of these decisions can be made in a somewhat principled manner. Typically though, the main thing that has the most effect is the pre-trained layers, like the pre-trained stuff and the transformer. Like those are the first things I would tweak. I would argue it's a bit of a gut feeling, but the research team is trying to figure out if there's something general to be said there. And on the couple of data sets that we have tried, we haven't found the hardest conclusion just yet. But if you have a couple of data sets for us to benchmark against, we would love to hear from you.
We had actually a question in the chat about, I think about downloading the presentation. So I believe we'll also make this available as well in the Meetup group. So should have access to that. We're also recording the session, so you should also have access to that as well, a little bit following the presentations in the Meetup. Do we have more questions here? Oh yeah, I see. So yeah, also Anonymous asked, does training data need to be grammatically correct? Not
really. I mean, so it depends on your architecture. But what you can do, and this is quite common, we see that this works reasonably well. When you take a word, let's say that has 5 letters, like I don't know, let's take the example Pokemon, just for randomly. Let's say I spell Pokemon without the O, so it'd be like Pokemon without any of the vowels. Technically, if I have a feature generation step before that would look at all the bigrams of letters, then Pokemon without vowels and Pokemon with vowels would still overlap to some reasonable degree. So there is some robustness that you can build in to guard yourself against spelling errors. And I would argue that that's a good thing because spelling errors in digital assistants are relatively frequent. But the bigrams of letters typically solve that reasonably well in my experience.
Awesome. So I think that might conclude the questions. Do you guys have any more questions? Feel free to just also throw them in the chat or into the Q&A panel in Zoom. Should be on the bottom. Should be able to see a little button there. Oh, great. We have a new one. Michael Bateman. Does Whatlies do document level embeddings?
You have to specify the correct language backend, but in essence, yes. So there's a very brief example I showed. At the moment, the only document level embeddings that I support are the Birch style transformers that Spacey supports. There is an open ticket, and I need to find some time for it, but there is an open ticket for proper Hugging Space models. And the moment when that's done, then we should also have document level embeddings for multi-languages. So that is something that I'm actively checking out.
Always stuff going on. And Thiago Guimarães asked, does Whatlies work with other languages such as Brazilian and Portuguese?
Yeah, so in essence, yes, and that's also the goal that I have. I want to have as many languages supported as possible. At the moment, I don't know if Spacey has Portuguese. I believe they recently added that. But I do also support fast text, and I can't imagine, like fast text has support for, I think, 157 models or so. So Portuguese has to be in there. It might even be the case that it has Portuguese as well as Brazilian separately. If you're having trouble with that, definitely add an issue on GitHub and I'll gladly have a look.
So next up, I have to say this is something I've really been looking forward to since we scheduled this meetup. Divyang Pradeep Pal, one of our contributors, is going to show you how to integrate a Rasa chatbot interface into Unity Engine, and he will share this his knowledge and show you how you might do that yourself as well. So over to you, Divyang.
Thanks, Emma. So hello, everyone. My name is Divyang, and today I'm going to share my journey about how I made this project where I integrated Unity with Rasa. At the end of this presentation, I hope that everyone would be comfortable with using Unity. I hope so, and maybe you'll get some ideas on how you can use Rasa along with Unity. The project which I'm going to show can be found on my GitHub, retrogeek46-Rasa Unity. I do hope that you come over here and try it out. So I'll first begin with why Unity. So Unity is a game engine in which you can create applications and games. But the thing is, not just games, but you can create other 3D applications as well, which you might have seen in places where people are using Unity for machine learning simulations or even filmmaking, because you can create 3D renders and animations. One of the key features are support for multi-platform. So you can create a project and build it for Android, Apple, Windows, Linux, using the same code, the same development. Then there is also extensive community support where you can find answers for all your Unity related questions, just like Stack Overflow. And as you can see in front of you, the editor also is quite easy to use. I mean, if this is first time that you are seeing the Unity editor, it might seem a bit daunting, but I'll just go through it in a while so that you can understand what's going on. Before that, I'd like to show you what I have built till now. So this, I mean, we've been talking about Pokemon bots for so long, and here comes another one. So in this bot, you can see that there are few Pokemons which you can cycle through. And then after you select it, UI scrolls down. This UI is an interface to interact with the Rasa chatbot, which is working in background. Now, here is the chatbot, which is running on a different screen. Now, what you can ask this chatbot, you can ask the type of the Pokemon. And it also supports voice recognition. So I could ask, what about its evolution? And now when I ask the chatbot, it will answer me what the evolution of Charizard is. So it goes from Charmander, Charmeleon to Charizard. Then you can close this chatbot, cycle around, select another Pokemon, and it goes like that. Now, how I build this system. So first of all, when using Rasa with Unity, the thing you need to work with before is sending data from Rasa to Unity and vice versa. For that, I have a script written in C#. This is also one of the reasons why I use Unity, is that it supports C#, which is a powerful language when creating applications. For working with Rasa and Unity, the main thing we do is first we create a custom connector in Rasa chatbot. And if you don't want to create a custom connector, then Rasa by default has a restful custom connector built in itself, which works absolutely fine for our purposes. After that, we create a post request with the message that we want to send wrapped in a JSON format. Now, one thing that is difficult when working with Unity is JSON. The JSON support for Unity is very rudimentary, and for that you need to create few helper classes, which you can find over here in the utils file. So you create classes and structures, and then you wrap them, and after that, using these classes, you can implement JSON functionality. Now, I would like to talk about a few things that are specific to Unity. When working with Unity, the things you see on the screen are rendered through the camera, which is this game object. Game objects are objects that are present in your screen and have components on them. So main camera over here is a game object which you can use to view the screen. After now, every game object has components which provide them with specific attributes. For example, the main camera object has the camera component, which provides it with the attributes which you can use to control how and what the screen is showing. For example, the transform component would tell you where the camera is located. So I can move it forwards and backwards, and that would change how the screen is rendered. After that, for the UI, I have created, so we have done camera components. And another thing I would like to introduce are prefabs. Prefabs are like prefabs are like instance of an object that you can create clones of. So it is like a parent object with properties that you can create clones of or instances of as many times as you want. Now the use that they give is, now the use is as follows. So as you can see, this is a prefab of user message. So whenever I would need to render a message typed in by the user, I would instantiate this message. It has a user bubble, this blue bubble that you can see, which is an image component, giving the, which gives the bubble its visual appeal. And beneath that is an empty game object, which only has a rect transform. With a rect transform is basically a transform for rendering canvas objects. And you can imagine the canvas being as a 2D a 2D layer on your screen for a 2D layer on your screen for showing information which is not rendered in the 3D space. For example, your HUD elements like the health bar, stamina levels, etc., or UI buttons. So these buttons do not move with respect to the entire scene. They are static and on the canvas. So when I render this, so when I have to render a user message, I instantiate this prefab and add components as in necessary. So for example, if I need to type in a text message, this message object will have a text component in it, which will be like this. So now you can see that there's text on it. Now all of this is done using a script, so that if I have to render a image, I can add an image component instead of a text component. Now I will talk about the code for this project. As you have seen that the project with, so I've talked about sending messages to the Rasa chatbot using post messages. Then when working with the bot UI, what I've done is, so let's play this again. And let me just turn off this sound. Okay, so now when I select a Pokemon, you can see that there is a scroll view, and this is the scroll view. So as you can see, this is a canvas, which is a 2D screen on which items are being displayed. And beneath these are these two bot bubble objects. These are prefabs which have been rendered using, which have been instantiated using the prefab over here. And as you can see on the message object, there has been a text component added using the script, which enables us to see whatever message the bot has whatever message the bot has sent. And now I'll just show you how that is done. So there is a method add chat component, which takes in arguments the UI, the prefab as a reference, the message and message type. So if it's a text message, I add a text component to the chatbot, to the chat message, and render it on the screen. Now, I would like to show the chatbot as it, which is working behind the screens. So, okay. So the chatbot works, the chatbot basically has two stories. The first one is when user does not ask, when the user asks a question and then an action is triggered. And when the Pokemon query is asked, the Pokemon which has been passed is saved in a slot over here. So using slots, I'm passing data from Unity to Rasa. And you can see those slots over here. So there are two slots, the Pokemon that has been selected and the query. For example, the supported queries right now are the type of Pokemon, the evolution, where it can be found.
Thanks, Divyang. It was actually so awesome to see this actually working from the background. I know that we've taken a look at this as well from, or at least I've seen it from a perspective of the tutorial that you've released as well, which actually I'd really like to share with everyone here as well. So I'm just gonna open that up and share with everyone. Maybe we have some questions in the chat. I'd actually like to, if you want to maybe just pop them in the Q&A section. Meanwhile, we're putting this together. Feel free to ask questions.
So video games, like, you know, I was also a teenager at some point. So every time I see a video game, I kind of go, oh, I wish I could make one. But Unity, I mean, it's not something that is arbitrary to learn. I think it's fair to say that there's some sort of a learning curve to Unity as well. You know, C# in a different environment. So I wonder, were you familiar with Unity when you started this project, or were you more familiar with Python and Rasa when you started this project?
So I've been working with Unity for around 3.5 years. I mean, I picked it up when I was in university.
Okay.
And I've been just playing around with it since then. I mean, when I'm not playing games or studying, I'm making games. And that's how I mean, that's one of my hobbies.
Sure.
And about learning curve in Unity, I think it's one of the easiest game engines that you can start with if you are into those kind of thing. For developers, Unity is one of the best game engines that you can get into. I mean, some alternatives are Unreal Engine and Godot engine, but they are more specific to visual, the visual side of the industry. I mean, like making things look more beautiful. I mean, not that you can't do that in Unity, but they are focused more on like AAA industries and those kind of things. So in Unity, I think developers would very much love to play around, and the learning curve is very easy because Unity supports a great community and there are lots of resources to learn from.
Yeah, I got the impression that Unity was definitely a little bit more friendly to the indie developers in that sense. That's also something they brand themselves as. But then the thing that I wonder that is interesting, like, were you very familiar with Python or not so much? Because one thing that I am interested in is if it's relatively, because you're using webhooks mostly, I think, right?
Yes.
Okay. Now, but what was it? Did you learn Python just for the Rasa specific use cases, or was Python already known?
So I learned Python after joining my work. So over there, and that's how I came out to know about Rasa as well. So
Okay.
we around 6 months. It has been 6 months since I've joined work, and we had to create a chatbot over there. So me and my team, we looked at the possible options like the Google, like the one given by Google or IBM. And in the end, we settled down on Rasa because it's open source, and that is a big plus where you don't have to pay anything. And we were like new recruits, so it's easy for us to work on new things, and our superiors were more than happy to like give us time to fiddle around, and that's where we started with Python as well.
Okay. Now, one thing I wonder then, because all the UI is basically handled over at the Unity side, but then the main thing I suppose you had to do was just handle a little bit of the data logic in Python, and everything else is just handled by Rasa and the stories and the data and those parts.
Yes, I mean, you do have to write some custom Python for the action server.
Yeah, that's true. Yeah, that's true.
I mean, I think that Python is an easier language to learn after you've been dealing with stuff like C#, C++. But I don't know how things would go other way around. I mean, if you come from a Python background, I think C# could be a little bit more difficult since there are more rules that you have to follow.
Yeah, and it's also a compiled language, so it's less
Mhm.
interactive. You have to think up front. That's the main thing I'm always confronted with. Like you have to think ahead. But okay, now that makes sense. Cool.
Awesome. Does anyone else have any questions in chat? Feel free. You can ask anything. I think in the meantime, I'm actually curious, Divyang. I know you've been a little bit talking about getting the voice integration. I know this is like, quite a big challenge, and but you've been talking to me a little bit about some of the ideas that you have. Do you have a little bit more to share about the sort of things that you're gonna work on next, and what you'd like to do next with this bot?
Okay, so as far as this Pokebot is concerned, I'm thinking of uh, combining it with an API so that instead of hard coding the responses, uh, it can fetch data from internet and become a much more robust bot. Along with maybe instead of this just 5 Pokemons which you can circle around, maybe maybe make a game out of it. Like if anyone has played Pokemon games before, so there are safari zones in which you can roam around and catch Pokemons. So the it could basically be a safari zone where you encounter different Pokemons, and then you can ask the Pokebot about what those Pokemons are. And for now, I've only added voice recognition, and later on, I think text to speech would be another great thing, combined with a robotic Pokebot like voice, the Pokedex voice, which we all are familiar with.
I'm actually kind of curious because let me put this feels like a realm where definitely some cool stuff could be happening, right? But could you imagine that at some point a chatbot could also be a video game? So I can definitely imagine, you can definitely build a chatbot that's entertaining, and you can definitely build a chatbot where you're trying to get a goal sort of across there. Is that something you've been playing with as well? That idea?
I've been developing or thinking about developing a game which works on similar principles. Uh, if you had to put it in a genre, it would be like a single player co-op game. I mean, if that even makes sense. So basically, what it would be like, the chatbot would be an interactable NPC, and you both need to work together and
Yeah,
maybe
exactly.
progress with the story. For example, uh, you need to go through a prison break where the person in your adjacent cell is a chatbot. So you need to converse with them, maybe build up your trust level, and um,
Yeah, it's kind of like an escape room of sorts.
yes.
And the cool thing, like, that my dad mainly played these games when I was like super young. But like back in the like 80s, 90s, when these adventure games would sort of start out, there was this interface you had before click and drag where you would have to type, "Hey, talk to this person," and that would be sort of the way that you would control the video game. And I can definitely imagine that you could have some sort of NPC adventure game kind of thing happen just from the talk line.
Yeah, I mean, the first thing that came to my mind was the prison break, which essentially is an escape room. And I've been working on trying to write a story and everything for it. And later on, as and when I have some progress, I'll just share it with you guys.
Oh, I'd love to hear that.
That would be so cool.
There's two reasons why. For starters, if something like that were to work, that's always a nice demo. But I also there's some nice non-trivial things you're gonna hit while designing such a system. I think because not every digital assistant is meant to also be a video game. So it'd be interesting to see what sort of problems you're gonna face when designing something like that.
I mean, the first one I can think of at the moment is how to save states, like how the story is progressing.
Oh yeah, good one. I mean, there's a couple of video games where if you lose, you have to start over again. So I guess you can maybe start with something like that. Uh, but definitely, yeah, that's a nice one. How do you properly save state? It's a good one.
Sheila asked, was the automatic speech recognition done in Unity?
On Windows platform, we are all aware of Cortana. So when developing for Unity on Windows, you can simply use the Cortana services. So it handles voice recognition perfectly well for these purposes. But if you want, you can also develop things using Google Cloud API, IBM Watson, and a few other things. But that will take a bit more development effort from you. I mean, I tried to work with the Google Cloud API, but I still haven't gone very far deep into it. And I think maybe sometime after this, I will try to integrate it and maybe make a tutorial on how that goes.
That would be really awesome. Thank you. That would be really, really cool too. If we had a tutorial, we could also share with the rest of the community. I think they would also really appreciate something like that. And how long, maybe a question for you as well, how long was the whole kind of process of you integrating, into Rasa interface into this Unity? What was the kind of rough timescale for that?
So just sending data from Rasa to Unity took me like 2 to 3 days, mainly because Unity has poor JSON support. But other than that, creating the UI took me like a week or two. And after that, all the Pokemon thing would be another week or so.
So I guess we're about time to wrap things up. Again, thank you so much for attending. It's been really awesome also to connect with you guys, and also I'm just it's really exciting also to see the projects you're working on, Vincent, and also Divyang. Really, again, thank you so much for taking the time out, and I'm so excited to see what's coming next with the Unity projects as well. I think it's it's going to be awesome as well. So let's stay in touch with that, and maybe at some point we can also share some more updates, obviously with community as well. So yeah, feel free to check our channels out, guys. I wish you a really nice rest of your weekend or rest of your day. And yes, the presentation, another question, yes, the presentation will be available. I'll make sure it's available in our building meetup group, but I'll also post it most likely on our forum and our other channels as well. Great, so yeah, thanks a lot, guys, and yeah, we'll meet again soon.
Have a good one.
Thank you.